All right, so since I know that we are all diligent observers of e-class page, and we go there each and every day to see what's new. Um, all of you are aware that next week we were taking those retests that we do every semester. So we're gonna review today, review Monday, review Tuesday, and then the tests that are up for retesting are the first three, not the one that you took yesterday. Yesterday's test will be retested at the end of the semester. Speaking of yesterday's test, all the grades are already in the grade book, so you can at least see how you did. But as far as when I'm gonna pass those back, to be honest, I really don't know where it's gonna fit into the schedule because we have these reviews the next 3 days. Okay, then on Wednesday, the retest is gonna be split up into 2 days. Wednesday we'll take the first half of the retest. Thursday we were supposed to take the second half of the retest, but that's still a little up in the air because Thursday I think there's gateway testing or something. Some of you might be doing that. So not only will some of you not be here Thursday, but then even it's an extended first period, so I won't even see my second period. So we're still, as a group, we're still discussing what to do. There's a good chance that gets pushed back to the following Monday. There's no school next Friday. Randy is speaking. Then that following Tuesday is midterm already. Again, this is all stuff you know. I'm going over things that you already know, but so as far as when I can fit in this test review, I don't know. I don't feel bad. I mean, from what I hear from other teachers, they don't even review tests. They wait until like milestones like this, like the midway point or the end of the semester to review them. I try to give them back to you in a timely manner, but I just don't know where it's going to fit in. Maybe Thursday, but even then, if most of you are not here on Thursday, I don't see the point in reviewing it there. So we'll see. TBA. Any questions on anything I said? All right, so let's just go through these together. We'll do as many as we can. The rest of it is yours to keep. You can take it home and work on this. This will be the type of stuff that'll be. So the way the retests are going to be arranged is it's 30 questions total. You'll take 15 on day 1, 15 on day 2. What's 15 plus 15? 30. 30 is also divisible by 3. This is going to be content on the first 3 tests you took. So what is 30 divided by 3? 10. So you will have 10 questions that correlate to each of the tests. If you do better on those 10 than you did on the original test, then the grade gets swapped out. I believe also it's going to count as a quiz grade overall, so that way people that want to not take it as a protest, it kind of forces them to take it seriously. Because even if you don't need it for the original test, you would still need it for a quiz grade. Yes. No, the quizzes are frozen. So like, quizzes get replaced by the original test. The original test gets replaced by the retest, but it doesn't like double dip. It doesn't go. Yes. Well, if you missed a quiz, that the original test should have already replaced it. So like in your case with this last one, which this is not even being retested, but yours already got replaced. Any other questions? All right. So here we go. The first one. These are square root. The first unit was on radicals. This is a square root equation. What do you want to do first? What do you want to do first on any square root equation? You square both sides. What do you want to do? Isolate the radical. The radical needs to be isolated. Luckily, well, it looks on all of these except for one of them. That's done for you. That's cool. Yeah, it's already done here. The reason why you want to isolate the radical so that way you can remove it. How are we going to remove a square root? Yeah, square both sides. I don't have a ton of space, so I'll take some liberties with some steps. Like for instance, this one here, I know that once I expand it fully, I would get X squared plus 14x plus 49. If you put x squared plus 49 and you forget the 14x, it's wrong. If you say, well, Mr. Romero, how did you get the 14x? Well, I'll let you discover that on your own by changing x plus 7 squared to x plus 7 times x plus 7 and FOIL and combine. That's what you'll end up with. If I had more space, I would do it too. Yes? No? Here, I'll give you Randy's. He hasn't written anything yet. I should just give you Mohammed's, but Mohammed's might have Drew on it. I don't think you want that. Mohammed, you see your test grade from yesterday? I'll take that as a maybe. All right. What type of equation has this now become? Quadratic. So let's treat it quadratic. Let's set it equal to 0. Minus 3x minus 19. Minus 3x minus 19. Now you have two options. What are the two most common options for solving quadratic equations once they have been set equal to 0? Quadratic formula or factoring. Anytime a is 1, I will go the factoring route, but it's up to you. Why did I put 14 again? I don't know how to add. Sorry, it should be an 11. I think I said 11, but I wrote 14. Sorry, but that makes more sense now. Can you think of two numbers that multiply to give you 30 and add up to 11? Yeah, 5 and 6. So 0 equals x plus 5, x plus 6. So that ends up meaning that x can be negative 5 and x can be negative 6. But wait, there's more. Because a square root has an even index, what do you have to do at the end? Check for extraneous solutions. My tip on my pen is bigger, so that's why it's part of the reason why it takes up so much space. You should be able to fit this in the space allotted, but I'm going to spill into this bottom problem here just to do the check. So if I plug in a negative 5, square root of 3 times negative 5 plus 19 would have to equal negative 5 plus 7. So this side gives me 4. This gives me 2, so 2 equals 2. Hip hop hooray, that works. You work. So square root of 3 times negative 6 plus 19 is equal to negative 6 plus 7. This gives you square root of 1. This gives you 1. So as Dennis said, that one works too. So I have two solutions here. Dabarak, you don't have a pencil? You don't have a pencil? Oh, you have one? Here, you gotta write it down. Any questions? All right, I'm gonna do the odds because I want to make sure that I get to every type of Did everybody write it down? Let me leave it on there because then you're gonna get mad at me. I'll do the odds first because I want to make sure I get to every problem type, and then if we still have time again, we'll just circle back. I'll do 4 instead of 6 though. Okay. How about this next one? How about 3? Yeah, it's already isolated, so we do the same thing. We square both sides. We get 9x minus 5 is equal to x squared plus 2x plus 1. If you're not sure where I got the 2x from, change it to x plus 1 times x plus 1, FOIL, and combine. Like they do in the hood. Minus 9x plus 5 minus 9x plus 5. 0 equals x squared minus 7x plus 6. What type of equation has this become? Can you think of two numbers that multiply to give you 6 and add up to negative 7? So 0 equals x minus 1 and x minus 6. So x equals 1 and x equals 6. You should also be checking for extraneous. So square root of 9 times 1 minus 5 is equal to 1 plus 1. This is square root of 4 is equal to 2. 2 does equal 2, so that works. The next one is square root of 9 times 6 minus 554. That's 49. Square root of 49 is 7. And 6 plus 1 is also 7. So that works out. Any questions? And you know what? Let's do I'll do 4 and 5. I think 4 and 5 should be enough. Alright, if you didn't write everything, go back and look at the video. First step on the let's do 5. Just go along the top. Let's do 5 first. First step, square both sides. The inside here stays the same. This just becomes x squared. Move everything to one side. Plus 2x minus 3 plus 2x minus 3. 0 is equal to x squared plus 2x minus 3. What two numbers multiply to give you 2 and add up? Sorry, multiply to give you negative 3 and add up to 2. 3 and negative 1. 0 equals x plus 3 and x minus 1. So x equals negative 3 and x equals 1. When I plug in the negative 3, spaghettios. Daisy. Here I get square root of 9, which gives me 3, but on the other side I have a negative 3. Is 3 equal to negative 3? No, so that's not going to work. Once I try out the 1, if that works, that'll be my solution, but if it doesn't work, what happens? Then I have no solution. No, I ran out of space there, so let's just do the 1 up here. Square root of negative 2 times 1 plus 3 would have to be equal to 1. This gives me 1. It does work out. Hip hop hooray. So that's my only solution. Why are we checking for extraneous, Abby? We already said it once today, so it should be an easy question. Why are we checking for extraneous? Steph, why are we checking for extraneous? Shina, why are we checking for extraneous? Calvin, why are we checking for extraneous? Anita, why are we checking for extraneous? Fine, let me rephrase. Why do we have to check for extraneous? Maybe that'll clear things up. Yeah, I know. It's the same guys that contribute each time, but then we say it's too hard, and the teacher doesn't teach, and the homework doesn't match the problem. There's always these different excuses, but I ask a question that I already gave you the answer to, and I can't get it. Gabby, why do we have to check for extraneous? Say it better. Dennis? Nah. Go ahead, Chase. Thank you, because the radical equation that we have has an even index. If you have an even index, you need the, and those are the ones you get most often. I think back when we took this, maybe you might have had one with an odd index, maybe. But the far more common ones are the even index. Now here's a different question. Should be an easier question, but now this one requires some understanding of math. Let's go back to Dennis. Dennis, what is an index? No, don't know that one either. China, what's an index? So when we say even index, you don't even know what we're talking about. Thanks, Randy. I'm not talking to you. Abby, what's an index? The what? Nah. Kaylin, what's an index? No. Anita? Nah. Steph, did I ask you already? Zora the Explorer, what's an index? Yeah, it's the little number that goes on the corner of the radical. But wait, what are you talking about? Are you blind? I don't see anything there. If you don't see it, it's a 2. Any other number you'd have to see. Yeah. All right, let's do number 4. Now, what's slightly different about number 4? Yeah, the radical is not isolated yet, so I would have to add 20 first before I can get rid of that even index by squaring. So I get 6x minus 29 is equal to, no, I have it right. 6x minus 29 is equal to 1. So it's slightly different here because there wasn't a variable. Because there wasn't a variable on the other side, what type of equation does this become? This is yeah, it's linear. So now I would just add 29 on both sides. 6x is equal to 30, so x is equal to 5. Dennis, do we need to check this for extraneous? Why? Oh, look at that. See? Good job, man. So we go now for the record, these are much more likely to check out. They don't have to, but they're like, I've seen them fail before, but the ones where you don't have a variable on the other side, they're much more likely to work. Minus 20 is equal to negative 19. This in here gives you 1. What's 1 minus 20? Negative. So I ended up with negative 19 on both sides. It works. What? Coach Godfrey had some nice things to say about you yesterday. About a lot of things. I haven't told him that we're going to steal you from him yet, but nah. Phone. Huh? I'm doing the odds. I'm trying to do the odds so that we can get to like one of everything. Because I doubt we're going to get to every single problem today. Huh? Which one are you scared of? Okay. No. Well, what's a 1/2 power the same as? No, it's a square root. So this is just the same thing as doing that. Okay, so here we go. This one goes out to Zora. In exchange for me doing this problem, she's gonna be a basketball manager next year. A 1/2 power. I don't have the space. I would rewrite it, but it's just the same thing as square rooting. So to get rid of it, you square. So we get 9x plus 22 is equal to x squared, and now everything else would be the same. Minus 9x minus 22 minus 9x minus 22. I think we've done enough checks for extraneous already, So just to save time, I'm going to bypass that, but you're supposed to. This gives you x minus 11 and x plus 2. So we end up with 11 and negative 2. If you do the check for extraneous, negative 2 is going to fail, but 11 is going to pass. Any questions? All right, then let's get to graphing radicals. Remember, the big thing about radicals is the end behavior. On one side, we have an endpoint. Let me rephrase. Not all radicals. Do we have any? See, yeah, we do have an odd index down there. An odd index has two arrows. It goes forever in each direction. The domain of anything with an odd index. Dennis, what's the index on number 10? 3, yeah. See the little number there, 3? The domain there is going to be all real numbers. Okay? But on anything with an even index, there's going to be an endpoint on one side, and then an arrow only going in one direction. So you got to keep that in mind. Huh? The what? Oh, yeah. You know what? I didn't see that. Thank you. Yeah, I thought that was the square root. Perfect. Yeah. All right, so anytime we graph, we still want to identify our transformation numbers here. This has an A of 1/2. C is just 1. What's H here? -3, good. And then K is -1. Who remembers the significance of H and K here on square roots? Oh, sorry, no, JK. I keep thinking it's the square root. Sorry, that's for the next one. Now, on the, well, it is going to be on the graph. It's just not going to be an endpoint. Like I could already put -3, -1 as a point if I want, but it's just not. If it were a square root, it would be the endpoint. Here, it's not. Okay. Look, I used to use. I don't know where I can fit this. When I don't know, just fit it wherever you can on your paper. But when I did this originally, I would use coordinate notation to do the transformations, but you guys seem to like the tables more, so let's just do the tables again. Okay. For all the x's, all I got to do is -3. For all the y's, I need to go times 1/2 and then -1. So I need some parent points. This is a cube root. So what? Okay. So ideally I would want numbers that are perfect cubes. 0, 0 is always going to work, but I don't need 0, 0 because 0, 0 is what became H and K. I already know -3, -1 is going to be there. You know what, let me write it because then now you're going to get confused. That's just what becomes that, H and K. How many points would be ideal for a cube root? How many points should I come up with? 5. I like 5. Okay. Really, we would want 2 points on either side of this, so I'm going to want 2 negatives and 2 positives. Also, if you're going to be clever about this, because we have to multiply the y times 1/2, if you want to avoid, but I don't know if it's going to fit. We'll try it. You should try to go for even numbers. So, like, do we know any perfect cubes that are even numbers? I do. 8, yeah. 8 would be great. So I'm going to do -8 and 8. The cube root of -8 is -2. The cube root of 8 is 2. So -8 minus 3 is -11. That's close enough. I can fit that in. 8 minus 3 is 5. Then over here, -2 times 1/2 is -1, minus 1 is 2. 1/2 of 2 is 1, minus 1 is 0. So far I got 3 points. Then -11 is a little bit outside the window, but not a big deal. But then that also tells me that I'm going to have to use cube roots end up looking like something like an S, but before it flips, or if it flips. I'm going to just have to use 1. I'm going to have to use 1 and -1. What's the cube root of 1? 1. What's the cube root of -1? -1 also, yeah. So This is -2. This is -4. This is going to be -0.5 or -1/2, and this, yeah, it did. And this is going to be -1.5. So these are the points here I want to graph. Yes. Should always show work. You will not have points deducted due to work, but you should always show work. I'm never going to encourage you not to show work. -11, -2 would be somewhere around here. 5, 0 would be around here. -2 and -0.5 would be around here. And then -4 and -1.5 is here. So the way this ends up looking is it's really skinny. Why is it really skinny? Because we did a vertical compress of 1/2. That's one transformation. What other transformations did we do? What? Translate left 3. And what else? Translate down 1. What's the range here? Yeah, the range here is also when you have an odd index, both domain and range are all real numbers. I'm gonna hold this. Gonna get that picture of you today in your shirt and tie. Yeah. I got it on me, so put that head back down one more time. What's the end behavior on this one? Remember, end behavior, the format is as x approaches somewhere, y approaches somewhere, as x approaches somewhere, y approaches somewhere. Yeah, -infinity. Y goes to. Also -infinity as x goes to +infinity. Yep, negative, negative, positive, positive. Even though this looks like it's going purely horizontal, it's angled down, and if you give it enough space, it will get down to -infinity. This is going up and to the right. If you give it enough space, it'll go on forever. Questions there? Okay, number 9. Now this is a square root function. Let's do the transformations first. Here, let's do so this has an a of 3, a c of 1, an h of 2, and a k of 1. So let's name the transformations first on this one. What transformations are we doing? What do you think, Shina? Shouldn't take that long. Go ahead. Huh? No, nothing horizontal. Compress, that would be C. C's not doing anything. Go ahead, Caitlin. Vertical stretch of? Yeah, vertical stretch. Meredith, what else? Good. You can throw in the word horizontal if you want also. That's fine. Translate, right, 2 units. One more. Good. Translate up 1. We'll worry about the end behavior afterwards and all the domain and range stuff. We can worry about that afterwards. Let's find our points. The x is just going to be +2. The y is going to be ×3, and then +1. So for here, the x's, I would like perfect squares. Now what used to be 0, 0, that's what's going to become h and k. What numbers are we allowed to put in for inputs here for square roots? Only positives, yeah, because you can't take a square root of a negative. And not only positives, you would want perfect squares. Luckily, there's no fractions to deal with. How many points should we have here? Well, no, at least 3. 4 would be the best if you can fit them, but 3 should be fine. So my perfect squares, I'll do 1, 4, and 9, and I'll see what I can fit after the transformations. Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So this becomes 3, this becomes 6, this becomes 11, which is a little bit outside the window, but not too bad. 1 times 3 plus 1 is 4, 2 times 3 plus 1 is 7, 3 times 3 plus 1 is 10. Yeah, so it's not too bad. I think I should be able to fit all 4 of these. And I'll get a nice little definition on mine. Now also remember that on a square root, the h and k, this 2, 1 here, that's an endpoint. So we got to make sure that we don't put an arrow there. Then we go 3, 4. This is going to look a little bit taller because what type of a transformation occurred? A stretch, vertical stretch. 6, 7, and then 11, 10. So a little bit outside here like that. And connect those dots. What is the domain here? To the positive infinity, but the 2 requires a bracket. Because we are touching the 2. Big Vic, what's the range? Yeah, that's the one we've been working on for the last 5 minutes. Thank you. 1 bracket to positive infinity. And then end behavior, which we know x goes somewhere. Y goes somewhere. X goes somewhere. Y goes somewhere. On the left side, what's happening? I remember this confused people the first time around. Because we have an endpoint on the left side, we're not going forever. There's not going to be any infinities. Where's the x going to? It is going to 2. Where's the y going? Because there's an endpoint, there is no infinity. It's stopping. So as x goes to 2, where does y go to? To 1. Now on the right side, we do have an arrow. Where is that arrow going with respect to the x-axis? To the right, positive infinity. Where is it going with respect to the x-axis? Also positive infinity. Bet. You do not have a retake tomorrow. Who is listening? When's the first retake? Wednesday. Thank you. Wednesday. Today review. Monday review. Tuesday review. You haven't been on my e-class page for a while? Did you? There's also a homework section to my e-class page so that you would know what we're doing each week so that you wouldn't go and like do the wrong homework assignment by mistake. Now the sad thing, I don't know what's worse, that or the fact that you're not the only one. Okay, 11. Let's list all the transformations. A, C, H, and K. I think we can do all of these. This is pretty fast. A here is -1. C is 1. H is. K is. En fuego. China. Since A is negative, what does that mean? When A is negative, what happens? Stephanie knows? No. Good. So we have an x-axis reflection. You're basically getting the A and you're breaking it into 2 pieces. If it's negative, x-axis reflection. If it's another number other than 1, then it's either going to be a stretch or a compressed. But because the other side is 1, nothing. It's just x-axis reflection. We move on. Is C doing anything? No. How about H? Translate to right. Translate right to. Is K doing anything? Yeah, and this was sad. These were meant to be like freebies, or as close to like easy quote unquote problems on that first test, but some people just couldn't figure it out. And the sad thing, like if you tell me that they still can't figure out where to find the numbers, I guess. But the sad thing is like they could actually identify the numbers, they just wouldn't know what the numbers would do. A, C, H, K. What's A? What's C? Okay. What's H? These are one of the ones that if C is anything other than 1, if C is anything other than 1, there needs to be a parentheses inside the square root. Is there a parentheses there? No. Now, the way that parentheses will come about is you'd have to factor out whatever C is. It has to be outside. So when I bring out that -1, that makes the inside x plus 1. And when the rest of it says x plus 1, what does H become? -1. And then K is 0. When A is 3/2, it's a stretch. What? But that's a fraction. Yeah, it's an improper fraction. What is 3 divided by 2? 1.5. Is 1.5 greater than 1 or less than 1? Greater than 1. So this is a vertical stretch. Vertical stretch of 3/2. What is C doing? Go, Stephanie. It's your moment to shine. I just called on you for a reason, Steph. I was showing off my pipes. When C is negative, what type of reflection is it, Steph? No! Thank you. When A is negative, x-axis. When C is negative, y-axis. And since the rest of C is just 1, that's not going to do anything. One more transformation to go. Good. Translate. Use the word translate. If you want to use horizontal translation, even better. Left 1. You do the opposite of what it says. What? Why is it not what? Oh, because you were in the potty. You have to factor. Anytime C is not 1, you have to factor. All right. Let's see for this next one here. A, C, A, K. What's A here? -4. What's C? 1. What's H? No, +2. K is 1. All right. So here's what we were talking about. Look at A. This is the one where people would be like, "Oh, it's a compression." No. Because A is negative, Stephanie. What's going to happen? Good. So the first thing is x-axis reflection. China, you following? Then in addition to that, we're still on A. We took care of the negative already. But then since A is 4, what else is going to happen? Vertical stretch. Vertical stretch of 4. Then what else? Translate right to translate up. Don't leave today without me giving you. I have to give you a pass for advisement. Did anybody else not take a test here yesterday? I already gave him his pass. What's your advisement? Oh, so you can't take it with him. Write the equations of the following graphs. Okay, so there's a regression. Normally these were given to you as multiple choice. We never did full regressions. Trying to think of an easy way to do this because H and K would be easy. I'm gonna skip these because I'm not gonna without the multiple choice aspect of it. It's not gonna I'm not gonna get it done in time. To do a regression, you would need to use like 2 points and then go backwards. I'm gonna confuse a bunch of you. What I will point out, like so let's say this was multiple choice. What would be the easiest? What do all three of these have in common? What type of function are they? They're all square roots. I can tell by the shape they're all square roots. None of these are cube roots. This is not highlighted very well, but let's pretend that's there. What would be the easiest? Like I'm gonna give you enough to be able to answer these if there were multiple choice. These aren't really fair questions because even the first time around we didn't do regressions without multiple choice. We just looked at the characteristics of it. So like watch A, C, H, K. A, C, H, K. A, C, H, K. Where do you always find H and K? The endpoint. The endpoint. So this is -3, -2. This one here is at 2 and 1. This one here is at it looks like 2 and 4. No, I just bubbled it bad, but it's 2 and 4. Then A and C are the ones where it would get kind of tricky. Okay, but what we want to look for is whether they're positive or negative. That's easy to tell. So remember, the parent function for a square root looks like that, right? So this one, A, obviously does not. What does it look like occurred there? An x-axis reflection, so I know that this is going to be negative. It also looks a little stretchier, so it's possible that the A could be greater than 1, but we're not going to get really into how to find A and C specifically. I wouldn't. That would require an entire lesson. C looks fine. C should be positive. How about this next one, B? Yeah, A would be positive, because we're not like it looks like if this were the original one, it didn't get flipped this way. It got flipped that way. It got flipped on the C, so C would be negative. And how about on C? It looks like it got flipped both ways. Not only did it get flipped this way, but then it also got flipped back that way. So they should both be negative. And that should be, by looking at those characteristics, that should be enough to get you through the multiple choice. Does anybody not understand that? The population of a small town as a function in time of years represented by okay, blah, blah, blah. Graph the function, making sure to label the scales and axes properly. All right, what are we measuring here? Yeah, years and population, years and people. Anytime you have time involved, that should be your x-axis. So that means that the y-axis will be population. Okay, graph, and then after how many years? Okay, we'll do that stuff algebraically. So here we have an A of 20, C is 1, H is 0, K is 80. So we're getting every input, and the x's are going to stay the same. So, and it doesn't tell us what the population, the time in years. It doesn't say. So we can leave this as 0, 1, 2, 3, 4, 5, 6, 7, 8. Because the only transformations are A and K. What do A and K both affect? Yeah, they both affect the y's. So let's see some points here. The x's are going to stay the same. The y is going to be times 20 and plus 80. Where's my endpoint going to be? At 0, 80, yeah. So 0, 0 ends up becoming 0, 80. How many points should I be able to put for a square root? At least 3. So let's go 1, 4, 9, which gives me 1, 2, 3. These stay the same, 1, 4, and 9. 1 times 20 plus 80 is 100. 2 times 20 plus 80 is 120. 3 times 20 plus 80 is 140. All right, so what would be a good scale then to go up with? No, definitely not hundreds. 30s? I don't like 30s either. 20 sounds good. I think I like 20 the best of all of them. There's not necessarily a 20, 40, 60, 80, 100. And I would put this as 200. I like that. So 0, 80 would be here. 1, 100 would be here. 4, 120 would be here. And 9, 140 would be here. And it looks like that. How many years would the population be 210 people? All right, these we want to do algebraically. We're not going to use the graph. I wish it would have said that, but so the people is y. So the 210 goes where y is. Minus 80, minus 80. So we get 130 is 20 square root of x. So divided by 20. That gives me 6.5. Then square it. What's 6.5 squared? Huh? It's like 40 something. Wait, that doesn't make sense. After how many years will the population be 210 people? Well, it might be. It might take a while because it looks like it's flattening out. Huh? 6.5 squared. 42.25. Alright, so whatever. It's not the best question. How many people will there be in 12.5 years? So now put that 12.5 where the x goes. So f at 12.5 is equal to 20 times square root of 12.5 plus 80. Just put that in the calculator all at once. Square root of 12.5 times 20 plus 80. Should be like in the 140 something, 150. How many people? We can't have 0.7 of a person. So round down. What happens if you round down? Just 150 exactly? Okay. Because you can't have 0.7 of a person. You can have partial years. When they want to know how many years, you can have partial years, but you can't have partial people. So let me see. Analyze the following graphs. Okay, we did this already kind of today when we did the graphs. We did end behavior. Here, does this have a max or a min? This does have a maximum. So there is no minimum. Where's that maximum? Really, it's at y equals -2, but if you put -4 and a comma -2, that's fine. People would miss this. Where's the x-intercept there? There is none. But where's the y-intercept? Yeah, at 0, -4. Is this increasing or decreasing? It's increasing, and it would do so wherever the domain is. The domain here is bracket -4 to positive infinity. That would be the same thing for here. Here, the domain and range are both what? Huh? 15? Oh, I'm sorry. Thank you. Decreasing. So when the domain and range are all real numbers, is there a maximum or a minimum? Nah, there's none of these. Where does that cross the x-axis? Where? At -1. Where does it cross the y-axis? At 1, 0, 1. Okay, look at this one. There's no graph. What's the domain? Well, you know the domain's gonna. Where's the endpoint gonna be here? Come on, let's finish this quickly. Where's the endpoint gonna be? At 3 comma 4, right? So the domain, has this flipped at all? No, so this is going to be to the right of 3. Which one here says to the right of 3? E. What's the range of any cube root function? Alright. You can do any of the rest on your own. Go to tutoring. Come see me during extra help. Go to Randy for extra help.